Okay, so what is really cool about what we're going to do next when we talk about average rate of change is we are actually going to calculate the average rate of change on two different types of polar function. Okay? There are two things we can do with the average rate of change. The average rate of change can tell us if the function is increasing or decreasing, just like with other functions. It can also be used to estimate values of the function. If I have a small window and I have a little line through 2 points, I can use that to approximate some values. Now, here is something really neat. I have the list right here. This skill right here, this will not be the first time that we can do this. We can also do this in 1.2, 113, 114, 2.5, 214, and here in 315. All of these lessons are where we calculate average rates of change between 2 points, and then we could be expected to estimate other values of a exponential function, a logarithmic function, and topic 13, topic 14 were just that first lesson where we were dealing with story problems, and we're being asked to do the average rate of change and like apply. So these are mostly like story problem type. Yes. Yeah. So let's kind of walk through these two examples and then we'll be back. Let's see. Blessing. There you go. All right. So example 4. We're going to use the polar function 4 minus 2 sine of theta from 0 to 2 pi, given in that third example. We're going to find the average rate of change of r with respect to the angle from 0 to pi over 6. Step 1. R of pi over 6 minus r of 0 over pi over 6 minus 0. It's the rate of change, right? I'm starting at pi over 6, and I'm seeing, I'm starting at 0, and I'm going to pi over 6 to graph that tangent line. Well, it's not a tangent line, but it's a secant line. But they're some similar ideas. Sine at pi over 6 is 1/2. So this is 4 minus 2 times 1/2. What's sine of 0?
Sorry.
It's okay.
Pi.
Sine of 0. So you're gonna circle over here. What's the y? Yes, good. Okay, sorry. No. I thought you said like pi over 2 or something.
No, I said pi and 2 pi.
Oh.
And then I was like, wait a minute.
Right.
Not right.
No, I gotcha. So this is divided by pi over 6. Let's calculate this. 4 minus 1 is 3. 4 minus 1 is 3. 3 minus 4 is -1. Answer, -6 over pi.
Yeah, you use that door opener.
Okay. So we can do this with any of those other types of functions that we've learned about this year. Okay. Now, based on this answer, is this radius increasing or decreasing? Yeah. So if the rate of change here is negative, Is the radius increasing or decreasing?
Oh.
No worries.
Increasing?
Ooh, try again.
Decreasing.
Why is it decreasing?
No idea.
Because it's negative.
Oh. Oh, yeah.
Negative.
Yeah.
Is decreasing because the average rate of change is negative. I believe in you, Jackson. All right. Now, my last example is we're going to use the average rate of change to estimate a value. Now we have to use the calculator here because because I'm in a circle, we don't know the exact value of sine of pi over 4, the sine of 0.4, or the sine of 0.6. Okay, so let's do a little calculations. So if I do r of 0.6 minus r of 0.4 over 0.6 minus 0.4, 3 plus 3 sine of 0.6 is 4.694 minus 3 sine 3, 3 plus 3 sine of 0.4, 4.168. This is divided by 0.2. 4.694 minus 4.168 divided by 0.2 gives me, oh, sugar doodles. I only have 2 decimal places. I'll use the whole decimal instead.
It's factor. No, I can't do math.
2.628. Now, as we think about the units here, what are the units of my radius based on this?
What do you mean?
Yeah, so this problem says that my radius is a particular set of units. What units are
Centimeters.
centimeters? Now, what is the radius? What is now? What unit is my angle? Good. So, what are the units for this rate of change? If my R values are centimeters and my angle is radian.
Centimeters. That.
It's true though. Now, see, estimate. So this is just an estimation. This is not the actual answer. Estimate R of 0.5 using the rate of change found in A. Now, what is unique about 0.5 in respect to the problem?
Oh, it's exactly the middle.
It is in the middle. I could do 0.45, 0.55. I could theoretically also do 0.7, okay? Because in this area, the rate of change is around 2.628, roughly. So if I have the rate of change, some sets of points, what function am I thinking about? If I have a point and the rate of change.
Point slope.
Bingo. Bingo was his name. Point.
NGO. NGO.
Point slope. Good. So just to remind ourselves, y minus y1 equals m times x minus x1. Except in this case, my x's are theta, my y's are r. It does not matter which of the points we're going to use. I'm just going to use 0.6 as my point. So I'm going to do y minus 4.694 equals my slope from part A, 2.628 times. Now I'm trying to find the value at 0.5. 0.5 minus 0.6. Okay, because I'm plugging in that 0.5. And this is a calculator pal, so let's do some calculations. 2.628 times negative 0.1 plus 4.694. My approximate answer is 4.4312. And so that's my estimate. Well, now let's find what it actually is. 3 plus 3 sine of 0.5. 4.4383. Ooh, would you say that the estimate is close?
Yes.
Yes, it is. Now, that's it. Oh, that's interesting. I don't know what I did yet. I don't remember which one I used yesterday, but I used a different point last year, and my estimate is a little bit different. But that's okay. Interesting. All right. That's it. So one of the things that when I did this yesterday, I'm gonna give you the rundown that I gave to class yesterday. Because I do think that there's a part of this that is important for pilots of humans. I can get this. Yes. We did a warm-up yesterday. That warm-up does the exact same math that we did in this fifth example. Now, here's what's unique about that warm-up problem. It was a free response question from last year's exam.
Dang.
We just did the first two parts. I didn't do the third part on that sheet in class yesterday. When we think about how throughout this class we can do this exact same thing with other functions, the polynomials, the piecewise, the exponentials, the logarithmic, and polar functions. If you circle those topics that I talked about earlier on that sheet, you will see a little breadcrumb trail from the beginning of the course to the end of the course about where we can use the average rate of change to estimate other values of a function. So it's sprinkled throughout. The process is the same. What is cool about this is the same as how we can actually view the Bible. Have you seen that picture that's like a rainbow arch with like different colors? Talking about the cross references?
Maybe.
talking about the cross-references in the Bible. There are, I don't always have them memorized. There are 63,779 cross-references in the Bible. And so, just like our Bible, that's like, I've read that some people say that it's the first hyperlinked book because there are connections everywhere from the Old Testament to and within the Old Testament and within the New Testament. Math, oftentimes we group things in categories, and yet there are overarching concepts that we can touch on from the beginning of the course to the end of the course. And so we're going to see that even more as we start AP review. We'll be working on the same types of conceptual skills as we review. So that's that. Cool. So you have, I gave you that sheet. That's part of the homework. Yesterday, I forgot to print off the 6 AP classroom questions. Okay. I have left that open until late tonight. Okay. So since there's time between now and the end of the day, I'd like that not to hang over your head over the weekend.
Yeah.
So there's 6 questions. So 6 plus 6, 12 homework questions.
Cool.
So
hopefully I will have time after school because I do have work tonight.
Yes. Well, it's good that we are. That is. Oh, I will then just say, I can switch the setting for a late submission if you turn it in tomorrow because I want you to sleep. I'll make it available that you can submit it. But I have it closed at 11:45.
Cool.
So,
I can still do it.
All right. I know there was a lot, but I'm glad that we're able to get through
Yes.
it all right now. So, all right.